We have the set A of these natural numbers, and they are ordered with the relation division, right? The first question we have to answer is whether this set is totally ordered. Then draw the Hasse diagram, and then considering A as part of the natural numbers, find the maximum and minimal elements of A, as well as the maximum, minimum, supremum, and infimum when they exist. All right, so let's go to A first. Well, the answer to A is trivial. It's not totally ordered, no. And the reason is we have two elements, for instance, 2, 3, so that 2 does not divide 3 and 3 does not divide 2, right? Remember, in a total order, one of the two relations must be true, right? So we cannot have this. So this is a partial order. It's a partial order. Well, it's not the only two elements for which this happened. 2 and 5 are also example of this, right? Now B, we have to draw the Hasse diagram, and for that we need to first find the minimals of this set, which are the elements that are not divisible by any other in the set. We have 2, 3, and 5. Okay, 2, 3, and 5, which are primes, and that's why they are minimals. 6 is divisible by 2, and 10 and 30 are even numbers, so divisible by 2. So these are the only minimals now. So let's draw them. For instance, here is 3 in this order, 2, and 5. Again, the reason to do this in this order is because it's going to be convenient to avoid crossing lines, etc. All right. Once we have determined this, the remaining elements are these ones, okay? And the minimals here are 6, of course. 10 is not divisible by 6, so 10. But 30 is divisible by 10 and by 6. So these are the only minimals. So we have these two new points in this second layer. And now 3 divides 6, 2 divides 6, and 2 divides 10, 5 divides 10, all right? And that's it. We have all relations. This is the reason why we ordered this way, okay? And finally, once we remove this, we are left with 30. 30 is here. 6 divides 30 and 10 divides 30. So this is the Hasse diagram. And finally, we need to find the maximals, the minimals. Well, the minimals are already known. They are 2, 3, and 5. These are minimals. Okay, these are down here. It's they are easy to spot. The maximal is also here. I mean, 30 is the only maximal. Not only that, it's the maximal, it's the supremum, and it's the maximum. Okay, it's the supremum because all the others are smaller than or equal to it. So that means that 30 is divisible by any other element here, as you can see, right? And there's no other smaller element that satisfies this property. So this is the smallest upper bound of the whole set. So this is the supremum, and since it belongs to the set, then it's also a maximum. There's no minimum. Okay, there's no element which is smaller than any other in the set, as you can see here. But there is an infimum. The infimum is 1. Okay, remember that n is a subset of A is a subset of the natural numbers. So you have to consider all the natural numbers as possible lower bounds. 1 is a lower bound from this relation, is a lower bound to any other set, right? Actually, to any subset of n, 1 is a lower bound, and is the largest lower bound here, because there's 2 is not a lower bound already. Okay, so 1 is the infimum, and it's not a minimum, right? Because there's no minimum, right? Does not belong to a set.